All right, so in our second section, we're talking about cones and pyramids. So just two of them, and I think they're relatively straightforward. So for cones, again, your lateral area is going to be everything but the base. So if you look at a cone, think about an ice cream cone. You're going to have one circular base, and it comes to the point at the top. So for a cone, your lateral area is going to be, like I said, no bases. And we're going to, again, think about if I unwrap this cone. So if I take this cone and I take the curved region, not the base, and I unwrap it, it may look something like this. So I'm going to try and stretch your imagination here. So what shape does that look like? Hopefully you said it kind of looks like a triangle. And if we find the area of a triangle, we take the area of the base times the height and divide it by 2. So if I take the length of the base, which is this curved region, and now I'm going to ask you to imagine if you rolled it back up to become a cone. So if I roll this back together to become a cone, again, just remember like our cylinder, we rolled it back up, that became the circumference of the base. That's exactly what this length here is on our curved triangle. So this is going to be pi times diameter for the base. Then for the height, it's going to be the height on the outside. So a couple things I need you to note. For a cone, I want you to draw this up here. Draw yourself another cone. That's a terrible looking cone. Sorry. So draw like a triangle, but don't connect the bases with a straight line. Connect them with a curved line. That's a little bit better. Okay, so a couple things that we need to look at. For your cone, you have the radius that you're used to. Okay, you have the height on the inside. And then you have this outside height. This is called slant height. And we use the notation L to represent slant height. Whenever you're doing surface area with something that goes to a point, like a cone or a pyramid, the surface area only deals with the slant height, not the inside height. Okay, so surface area, slant height, they both start with S. Okay, so like I was saying, what we want to do is, with our cone, to find the lateral area, you're going to take the base, that was pi times diameter, times the height of the our triangle, or if I put it back together, that's going to be the slant height of the whole cone. So I'm going to take the area of the base times the slant height and divide it by 2. That's going to give me my lateral area. Alright, so let's go ahead and try the one down below and do the lateral area. So lateral area is going to equal 12 pi, because that's the circumference of the base, times the slant height. But remember, the slant height is on the outside. I don't have that. So if you see this triangle on the inside, it's a right triangle. Right triangles, you should automatically think the old dead guy, Pythagorean theorem, to find that third side. So if you did the Pythagorean theorem, this one should be 10. So I'm just going to multiply this by 10, and don't forget I got to divide that by 2, because it's technically like a triangle. So this is going to be 60 pi. Alright, so that's your lateral area. Your then surface area is going to be your lateral area plus 1 base, okay, because there is only 1 base in a cone. So surface area is going to equal your lateral area of 60 pi plus the area of 1 base, 36 pi. So your total is going to be 96 pi. Okay, almost done. The last thing that we got to talk about is volume. So with volume, just like before when we had a prism and a cylinder, we said it was the area of the base times the height. Well, with cones and pyramids, you're still going to think about it in terms of the area of the base times the height, but these objects are smaller. Okay, I'm going to use H to represent the height on the inside. Okay, this is the inside height on our cone. The way this is different, if I had a cylinder with the same radius and the same height that a cone does, the volumes are not going to be the same. So the volume of the cone is actually 1/3 the volume of the cylinder. So you're still going to think about the area of the base times the height, but you're going to divide it by 2 because I always say if it has a point, if everything comes to a point like a cone does, the volume is going to be divided by 3. So let's go ahead and find that volume of this down here. So volume is going to be 36 pi, that's the area of the base, times the inside height, which is 8, and you're going to divide it by 3. So if I do 36 times 8 divided by 3, I'm going to get 96. So like I said again, sometimes your surface area and your volume are going to be the same, but it's the units that really make a difference. Alright, so those are cones. Now let's talk about pyramids. Pyramids are very much like cones where they have a base and the lateral area. With the pyramids though, you're not going to have a circular base and you won't have just one shape for a lateral area. You're going to have many different shapes for the lateral area in a pyramid. In some you'll have a rectangular base and others you'll have a square base. But the lateral area and the surface area stay pretty much about the same. The lateral area is again going to be everything but the base. So in this case, if I look at this pyramid down below, if I eliminate this base, what types of shapes are left on the sides? Hopefully we all said triangles. So if I have the lateral area, I'm going to say, like I said, everything but the base. So triangles only. Okay, so let's go ahead and find that right now. It says given a square pyramid, so let's pause there. Square pyramid means that I have the base is a square. There are lots of things. So rewind. Prisms, we knew the base is based on the name. That's the same thing with a pyramid. It's going to tell you what the base is by its name. A square pyramid, a rectangular pyramid, an octagonal pyramid. It's going to tell you what the base is in its name. So, if I have a square pyramid, the base is a square, meaning all these sides are going to be equal. Okay, now I can go on. The height is 12 and the slant height is 13. So if the height's 12, that means that it's the inside height. So let's draw the inside height here. It's always going to go to the middle of the base and it's always going to be a right triangle, or right angle. And now I'm going to go ahead and draw the slant height in. That's going to be perpendicular, and that's again going to cut the sides in half. So this is 13 and this is 12. So what we're looking for is the lateral area. So I need to find the area of the triangles. Since this is a square and all 4 sides are going to be the same on the bottom, that means all the triangles are going to have the same base and they'll have the same height. So everything will be, the triangles will all be congruent. So I need to find this base somehow. I need to find a side length of the base. Well, if you look inside here, you have one leg that's 12, a hypotenuse that's 13, and if I make this green line here, I make a right triangle inside the figure. That's fine. So I can use the Pythagorean theorem to find out that that green line is 5. Well, that green line and this half the length of the base are going to be the same, which means this other side of the base is going to be 5 as well, making the whole side of the square 10. So now that I know the sides of the triangles, I can go ahead and find the area. So I'm going to take 4 times 1/2 the base of 10 times the slant height, because I'm doing surface area and they both start with S. So I'm going to use 13. And let's see, 10 times 13 is 130, and then the 4 times 1/2 is 2. So I believe this comes out to be 260. So my lateral area equals 260. All right, lateral area is done. Let's go back up to surface area. Surface area is then your lateral area plus base. So if I go back, my lateral area, like I said, was 260. And I'm going to add the area of the base. So the length times the width of the base, it was a square, so it's going to be 10 times 10, or 100. So my surface area is going to be 360. Okay, last but not least, your volume. Much like the area or the volume of a cylinder, it's going to be the area of the base times the height, and you're talking inside height, all over 3, because it comes to a point. So if it comes to a point like a cone, like a pyramid, it only has one base, you're going to divide the volume by 3. So the area of the base was 10 by 10. The height, am I going to use the inside height, or I'm going to use the slant height? I'm not going to use a slant height because slant height starts with S, and so does surface area, and I'm not finding surface area, I'm finding volume. So I'm not going to use the 13, I'm going to use the inside height. I'm going to use 12. And I'm going to divide that by 3. So I believe that's going to come out to be 400. So that's your volume. Okay, so go ahead and try the practice that's labeled cones and cylinders. There is no exit slope for that. That is just one worksheet. We'll put it together with the composite figures.